Hello, my first video after the winter break, and excited to be back. And we're going to do a video today which is very similar to other videos that I've already produced on the conservation of momentum, and that's what this is going to be. If you go to problem set 5 and read exercise 12, shut down the video, put it on pause, read exercise 12, and then come back, okay? Now, welcome back. Valentina is a cosmonaut, Russian cosmonaut, and she is going for a spacewalk. Well, she's actually not walking, she's floating. But we're going to assume that relative to the problem that she's going to be going nowhere, that she's going to have a velocity, an initial velocity of 0. That's important to understand that. It's an assumption, but for the sake of the problem, we're going to put down that Valentina has an initial velocity of 0. And she's holding the camera. So the camera is going to have an initial velocity of 0. Now, if that's true, I know, because of the conservation of momentum, I know several things. The first thing I know is that the initial momentum, the initial total momentum, will equal the final momentum, and that the mass of Valentina and the camera that she's holding times their velocity, which is 0, is going to be 0. So that's what their velocity times their mass is going to be. It's going to be 0. 0 what? 0 what? Momentum. 0 mass times velocity, kilograms times meters over seconds, kilogram meters over seconds. Okay, that's it. Okay, good. So it's kilogram meters over second. Okay? That's going to be their initial velocity. Now, what I've done is, and maybe you should do this too when you take the quiz, is that you should know physically, and it's very important, it's not just a label, it's not just something you tack on. Maybe you've done that in other science courses, but the correct unit label tells me that you understand what it is you're calculating. That's very important. So, what I've done is this. This is the table. Let me introduce you to the table. This is the initial velocity of Valentina, the initial velocity of the camera, the final velocity of Valentina, the final velocity of the camera, the initial momentum of Valentina, the initial momentum of the camera, the distance to the ship, 15 meters. Distance to the ship, 15 meters. The final momentum of Valentina, the final momentum of the camera, the change in velocity of Valentina, the change in velocity of the camera, the total initial momentum, the total final momentum, and I've filled in a few of the things already. Well, let's see. Read the problem. It says that she's carrying the camera, she's away from the ship. Let's not look at the problem too much right now. You've read it. I simply want you to know that, and there's an assumption, that her velocity is 0, the camera's velocity is 0, initial. Therefore, their initial momentum is going to be 0. Valentina's initial momentum is 0, the camera's initial momentum is 0, the total initial momentum is 0. So what I've done is I filled in the zeros. The initial velocity of Valentina, the initial velocity of the camera, the initial momentum of Valentina, the initial momentum of the camera, the total initial momentum, total of the system. The system is the camera and Valentina. Okay. The final momentum equals initial momentum, so these are 0 as well. Therefore, this is going to equal 0 kilogram meters per second. Yes? Okay? 0 kilogram meters per second equals 0 kilogram meters per second. Okay. Now this is what I want you to do. I'm going to go do a part 2. We're going to do a part 2 of the video. And this is what I want you to do. I want you to fill in the correct sign, I want you to fill in the distance, which is right on the problem. I want you to fill in the velocity of the camera and its sign. I want you to understand that that's what we're calculating. That's the first thing you have to calculate. And the change in velocity of the camera. That's all I want you to do. Oh, one more thing. I want you to put down the final momentum of the camera. Okay? 1, 2, 3. I want you to do that. I want you to do the correct sign, the direction, and the magnitude. Now, I started to talk about it. Let me just, real quick. Meters per second is velocity. Meters per second. Kilogram meters per second is momentum. Meters is distance. Kilogram meters per second is momentum. Meters per second is velocity. Kilogram meters per second is momentum, and seconds is time. Okay. Now, I want you to do, that's it. First step. Okay? Part 2 will be to be able to put in those values. Be right back.